Welcome to ilectureonline, and in this video we're going to show you a different way in which you can get the results of the Markov chains. In other words, how can we get the second state or the third state or the fourth state given the initial state and given the probability matrix? Well, it turns out in the previous videos we've shown that if you start with the initial state, you can calculate the first state, the state right after the initial state, by taking the initial state and multiplying it times the probability matrix. That gives you the results of the initial state. If we then take that of the first state, if we then take the results of the first state, multiply it times the probability matrix, we get the results of the second state. If we then use the second state, multiply times the probability matrix, we get the result of the third state, and so forth. And that's why we call it a chain, because you just keep doing the same thing over and over and over again. So based on the probability, you can then predict what's going to happen in the future. But what we could do instead is, instead of solving for the second state in this way, we can actually do it as follows. We can take the initial state, multiply it times the square of the probability matrix, and that'll give us the second state. Or we can say that we can take the initial state, multiply times the probability matrix to the third power, and then we can then find the third state and so forth. So let's go ahead and try that. And here I already have the results of the first state, the second state, and the third state. That depends on the initial probability matrix. So let's go ahead and multiply the probability matrix with itself, simply squaring the probability matrix, then plugging that in here, multiplying that times the initial state to get the second state, which should be the same as the result we got over there. So let's go ahead and see if we got that right. So first we have to multiply the probability matrix with itself. So 0.8 times 0.8 plus 0.2 times 0.1 plus 0.1 times 0.1. So we multiply these elements times these elements to get this element right over here. That'd be 0.64 times 0.66. That'd be 0.67, 0.67. Okay, so next we're going to multiply this row times this column. This row times this column to get this element right here. So this row times this column, that would be 0.31. So 0.31. All right, so we just continue doing that for all 9 elements. So we have this row times this column to get that element. So it'd be 0.02, so 0.20. So we've got 3 of the elements, we got 6 to go. So now we're going to multiply this row times this column to get this element right here. So 0.08, 0.17. Now we're going to multiply this row by this column. So 0.02, 0.09, 0.15. Quickly add these together, 9, that's okay, that's correct. And now I'm going to multiply this row by this column, so 0.01, 0.04, that would be 0.40. And again, the third column also adds up to 1, so I know I multiplied those 2 probability matrices together correctly. I'm now going to take that result and plug it right in here, so I end up with 0.67. 0.15 and 0.40. All right, now I'm going to multiply the probability matrix squared times the initial state, and that should give me the second state. And of course, that should be the same as what I got over there. So let's see if we got the same result. So I'm going to multiply this row times this column to get the first element. So 0.67 times 0.4 plus 2 times 0.36 equals, I got 0.414, and that's the same result. So far so good. So 0.414. Now I'm going to multiply the second row times this column to get the second element. So 0.18 times 0.4 plus 0.36 equals, I got 0.346. And that's exactly the same as I have over there, 0.346. And finally, I'm going to multiply the bottom row times this column to get the third element. And let's see if it's the same as this number right there. So let's find out. So 0.15 times 0.4 plus 0.4 times 0.36 equals 0.240. 0.240. And sure enough, this here is the same as what I have over there. So I know I did it correctly. So you can see that you can find the second state, the third state, and so forth by simply getting a power of the probability matrix multiplied times the initial state to get that state. So now we're going to do it again, but in this case we're going to find the probability matrix cubed. So I'm going to dig the result and put it in there and see what we get. So 0.67, 0.31, 0.15, and 0.40. So I'm going to multiply this times this to get p cubed. All right. This will take a little bit longer, so bear with me. Times 0.8 plus 0.2 times 0.1 equals, and this will give me 0.587. All right. Again, so this row times this column, so 0.67 times 1 equals 0.371. This row times this column, it's a long process, but just hang with me and we'll get this done. 0.67, 0.4 times 0.1 equals 0.454, 0.454. And finally on the second 5. And again, if I add these together, that would be 5, that would be 1, yep, that also adds exactly 7, 8, 9. Yes, that adds up to 1 as well. Okay, so far so good. So last row, last column right here. All right, so bottom row, 0.156 equals 0.3. And notice when I add that column together, it adds up to 1 as well. So now we have the probability matrix cubed. If I plug that in here, I get 0.587, 0.37, and 0.300. Now to get those 3 elements, I'm going to multiply this times this, this times this, and this times that to get the 3 elements right here. They should be exactly the same as x sub 3, which is equal to that. Let's find out if we got that correct. At 0.587 times 0.4 plus 0.36 equals, I get 0.424. And when I look over here, I get the exact same result. So it looks like I'm on the right track. Now I'm going to multiply this row times this column to get this element. So 0.36 equals, and I get 0.356, 0.356. All right, and now finally I'm going to multiply this times this to get this element right here. So 0.17 equals, and 0.220, 0.220, which is exactly what over there have the same results. So notice I can get the same result for state 3 by multiplying it 3 times in a Markov chain, or simply taking the probability matrix, finding the cube of that, and multiplying times the initial state right here to get the third state right there. So you can see there's 2 methods now of finding the nth state. So if you want to generalize it, so you can then say that x to the n, that's the nth state, or x sub n with the nth state, is equal to the probability to the nth state, or the probability matrix to the nth state, times the initial state. And that's what we learned in this video, that there's 2 ways which you can find the result. Using the Markov chain, 1 step at a time, or simply saying I'm going to take the probability matrix, raise to the n power, and then multiply times the initial state to get the nth state. And that's how we did that.